In this video, we are going to be going over my beginner's guide to REST. RESTful web services. Because of their simplicity and versatility, RESTful web services have really become a de facto standard in developing today's applications. REST stands for Representational State Transfer. The representation is typically going to be JSON or XML. The state transfer, that's going to usually be done by HTTP. This concept was established by Roy Fielding in his year 2000 doctoral dissertation. Now, what is REST in a nutshell? REST APIs are going to be using HTTP verbs to create, manage, and delete server-side resources. For example, get is used to get a resource. Delete is typically used to delete a resource. Resources can be data structures that are represented by JSON and XML. This is the most common use case. Now, the HTTP verbs are going to be used in conjunction with HTTP status codes used to communicate success, failure, or other errors. Now, it's important to note that REST is not a formal standard. The doctoral dissertation came out, the industry agreed upon it, and it was more of a general agreement. There's not a committee's body behind it. The SOAP APIs were very popular in the early 2000s, especially around .NET shops. They really seemed to like the SOAP APIs. This had an XML schema, a document, a formal structure. There was a rules committee behind it. There was a consortium, an industry consortium. REST does not have that, so there are no like chiseled in stone standards for REST. But generally today, 20-something years later, after that paper was published, the industry does agree largely on how REST should and should not be implemented. But it's important to note you will see edge cases where you have to adjust to something that you do not believe is part of the standard. RESTful terminology. Verbs are going to be HTTP methods like get, put, post, delete, and even patch. Messages are going to be the payload of the action, typically JSON and XML. A URI is a uniform resource identifier. This is a unique string identifying a resource. So here we have a URI with network information, the HTTP, is the protocol to call the website and www.example.com. The second example, I'd be asking or working with the book with the ID of 1. So book/1 would indicate books with ID 1 in a RESTful terminology. Now, idempotence, we talked about this previously. Idempotence is the property of certain operations in mathematics and computer science where they can be applied multiple times without changing the result beyond the initial application. In other words, you can exercise that multiple times without changing the result. So, for example, refreshing a web page, that is going to be an HTTP GET operation. For a static resource, you should get the same result every time. Also, REST is stateless. The service does not maintain any state. So this is very important. So this does not have any type of state in terms of a traditional context. You do have HateOS, hypermedia as the engine of application state. This is a concept that you will see in advanced REST APIs. Per Wikipedia, a REST client should be able to use server-provided links to dynamically discover all the available actions and resources it needs. As it proceeds, the server responds with text that includes hyperlinks to other actions that are currently available. So basically what this is saying, in a HateOS environment, the RESTful API is going to tell you more about itself as it responds. So this is an important concept. You don't see this that often, but more advanced REST APIs do provide this information. Now, HTTP GET, that is going to be used to read data from a resource. So read only, it's idempotent, it is a safe operation, does not change state of a resource. And as we go through these, I like to think of a CRUD operation. So this would be the read in CRUD if you're used to thinking about database operations. Here we have the HTTP put. This is going to be used to insert or update. So insert will be if it is not found, and update will occur if it is found. This is idempotent. Multiple puts will not change the result. It's like saving a file multiple times. If you save the same file multiple times, the same file will be saved. This is not a safe operation. It does change state. And this here is a special case in terms of CRUD. It's going to be create and update. Next, we have HTTP post. This is used to create a new object insert. This is also non-idempotent. Multiple posts will create multiple objects. not a safe operation. It does change state. This is the only non-idempotent, non-safe HTTP verb. In this case, this is the C in CRUD. Next, we have HTTP patch. This is going to be used to partially update an existing resource. So you can update like a field, for example, using a patch operation. Again, this is not idempotent. Multiple patch requests may change state. Typically, in most use cases, it is going to be idempotent, but it is not required to be. So that's important to understand. This is not a safe operation because it does change state of a resource. And in terms of CRUD, this is going to be an update operation. Then finally, we have HTTP delete. This is going to delete an object or a resource. This is idempotent. Multiple deletes will have the same effect and behavior. Not a safe operation because it does change state of a resource. And then finally, you can see here, this is the final CRUD. This stands for the D in CRUD, which is a delete operation.